Add walks in a straight line from point P to point Q with constant speed. Add starts from point P at time t is 0 and arrives at point Q at time t is 3, where t is measured in hours. Given that at time t, add's position vector relative to the origin can be given in the form R vector is A vector plus t multiplied by B vector, find the vectors A and B. So this situation looks like this. There are 2 points, P with coordinates -1 and 4 and Q with coordinates 4 and 16, and there is the origin somewhere with coordinates 0, 0. And if we consider the equation of a line in general, position vector of any point on the line, R vector, position vector means it starts at the origin, can be described as position vector of any point on the line plus parameter multiplied by direction vector, and direction vector is absolutely any vector of absolutely any length which is parallel to a given line. But if we consider motion, t means not just parameter, it means time, and we can see that when t is 0, R vector automatically equals A vector, hence A is the position vector of the starting point, and here the starting point is P, hence A vector is OP vector. And how to find coordinates of a vector? It's just coordinates of the endpoint minus the coordinates of the starting point. So it's -1 minus 0, 4 minus 0. And you can notice that coordinates of a vector will have the same values as coordinates of a point. And coordinates of a point and coordinates of a vector have different meanings, but the same values, because the starting point is the origin. It's only for position vectors. Hence, it becomes -1, 4 plus time and multiplied by the vector b, and vector b here means velocity vector. It cannot be just arbitrary chosen vector which is parallel to a given line, because if we consider magnitude of this vector, of the velocity vector, it's speed, and speed multiplied by time is equal to distance, and it is given, for example, that when time is 3, distance traveled is pq distance. So the first way to find velocity vector, we can use that information that when t is 3, distance traveled is equal to pq, and pq, distance pq can be found as the distance between 2 points. Formula is given in a data booklet. Or we can consider vector pq and find coordinates of a vector pq as coordinates of the endpoint minus the coordinates of the starting point. So it becomes 4 minus -1, 5, 16 minus 4, 12, and then pq, distance pq, as can be found as magnitude of the vector, and it is equal to a square root of the sum of squares of its coordinates. So it's square root of 5 squared plus 12 squared, it's square root of 169, it's 13. So pq is 13, and we know speed multiplied by time is equal to distance, but how to find speed, or how to set speed? If we write coordinates of the vector b1 and b2, we can see that there will be 2 unknown variables, and we cannot calculate 2 unknown variables from one equation. But since it is moving in direction pq, vector b, or velocity vector, will be parallel to pq vector, or any other vector which is parallel to a given line. And we know that if two vectors are parallel or collinear, collinear means that they lie on the same line or on parallel lines, coordinates of such vectors are proportional. It means that coordinates of the velocity vector we can write as 5k, 12k, where k is some constant to be found. And now speed becomes square root of 5k squared plus 12k squared, which is 13k, and hence speed, which is 13k, multiplied by time should be equal to distance traveled. And we can see that k is 1/3, and hence velocity vector becomes 5/3, 12/3, which is 4. Hence, position vector of any point, or actually it means here adds position vector relative to the origin, becomes -1, 4 plus t 5/3, 4. Notice that if we consider an equation of a line in general, we can take any multiple of this vector to be the direction vector. Another way to find the vector b. We know that at time e3, add is at point q, so position vector is 4, 16, and it is equal to -1, 4. It's clear that a vector is position vector of the starting point, plus since t is 3 we write t, and for vector b we write b1, b2 to be coordinates of this vector, and hence we get simultaneous equations, and we can see b1 is 4 minus -1/3, which is 5/3, and b2 is 16 minus 4 divided by 3 is 4. The next part, Roderick is at point C with coordinates 11 and 9. During Ed's walk from P to Q, Roderick wishes to signal to Ed when Ed is at the closest point to C. Find the time when Roderick should signal to Ed. So we need to find a point, let it be K, so that CK is the closest distance to the line, and we know that the closest distance is perpendicular distance. And point K, as any point on the line, is described by this equation. So position vector over point K is also can be given by this equation, or if we write coordinates over point, it will be -1 plus 5/3 t, 4 plus 4t. It means position vector, it means coordinates over point. We get the same result because vector can be obtained as coordinates of the endpoint minus the coordinates of the starting point, but if we consider position vector, starting point is origin 0, 0, so we get the same values but different meanings. And if we consider CK vector and coordinates of this vector will be coordinates of the point K minus coordinates of the point C, so it becomes -1 plus 5/3 t minus 11, so it will be -12 plus 5/3 t, and 4 plus 4 t minus 9, so it's -5 plus 4 t. And since CK is perpendicular to PQ, if we consider any vector which is parallel to a given line, hence two vectors will be perpendicular, and we know that for perpendicular vectors the dot product is equal to 0. So we need any vector which is parallel to this line, so we can consider PQ vector, or actually this velocity vector, it doesn't matter. And PQ vector has coordinates 5, 12, and CK dot product PQ should be equal to 0, and dot product is x by x plus y by y, so it becomes 5 times -12 plus 5/3 t plus 12 multiplied by -5 plus 4t should be equal to 0. and it becomes negative 60 plus 25 over 3t minus 60 plus 40 80 is 0. Negative 120 plus 25 t over 3 plus 4080, let's make a common denominator, so it will be 144t over 3 is equal to 0. So finally 169t is equal to 360, hence t is equal to 360 divided by 169, and it is equal to 2.13 hours to 3 significant figures. Or another way to find the required value of t, and if it is needed to find coordinates or position vector of this point k, we just substitute the obtained value of t, substitute in the equation for the position vector, and we can find coordinates of a point as required, but it's not needed here. Another way to find this value of t, if we consider distance ck as distance between 2 points, the formula is given in a data booklet, and it's a square root, coordinates of k minus coordinates of c, so it will be k minus coordinates of x coordinate of k minus 11, so it will be the same value, negative 12 plus 5 over 3t squared plus y coordinate of k minus y coordinate of c, it will be negative 5 plus 4t squared, and this distance must be minimum, and minimum or maximum it's about it's about turning point, and turning point its first derivative is equal to 0. So if we consider derivative of this function and equate it to 0, we can find the required value of t. Or we can differentiate directly this function, or since square root of something is minimum, then this expression under the square root also will be minimum, or if we consider ck squared, it's just negative 12 plus 5 over 3 t squared plus negative 5 plus 4t squared. So if ck is minimum, ck squared also will be minimum, so we can differentiate this. And if we consider derivative of ck squared with respect to t, it becomes, we can see something squared, so we apply chain rule, and it looks like function squared. It becomes 2 multiplied by this function and multiplied by function derivative, so negative 12 plus 5 over 3t derivative, and it's just 5 over 3 plus again something squared. It becomes 2 multiplied by negative 5 plus 4t, it's again chain rule, multiplied by negative 5 plus 4t derivative multiplied by 4, and it should be equal to 0. We can cancel 2 and we get the next negative 60 over 3 plus 25t over 9 minus 20 plus 16t is 0. It's just negative 20, and it becomes negative 40, and let's multiply each term by 9, and we get negative 160 plus 25t plus, and 16 multiplied by 9, it's 144t is equal to 0, and again we get the same result, that 169t is equal to 360. 169t is equal to 360. It's absolutely the same result as required, so we get the same value for t, and it's the required answer. And that's all for this question.